but present the mouse.
Yes, yes. So you can use it, or you can use it now.
Yeah, yeah. Okay. Okay. So welcome to my part, my tutorial. It's scheduled for 1.5 hours. Probably it's too loud, I think, or not. It's 1.5 hours, but if organizers decide that we need to finish at some time, so I can do. But anyway, if it will be 1.5 hours, I think we need to have a break. I don't know how. We don't have now break. So anyway, so my part is really, I would say, educational, because you've seen, I've seen many people was reading something during previous presentation, but even in the last slide, you've seen cloud native keywords. At least you should understand this is related to cloud. And what happens? Cloud became technology actually starting from 2011. And currently, even nobody can actually live without cloud. And what happens is 5G. 5G declared that they will use cloud native approach to design, operation, and maintain deployment of all services at the level of network function virtualization. Why? Because slicing is actually composing network of different programmable components. And how do you do this? There are two approaches. Either you do, okay, three approaches. You do this separate VM, okay, computer for any function is still loud, yes? Okay, so using a separate computer for any function that is virtualized, or using VM, and currently trends is using container, and even replacing the container management for cloud platform with Kubernetes. And I will, everything with this, I will show on my next slides. Okay, just slightly give you my background. I'm a researcher at University of Amsterdam and a lecturer on the courses like cloud computing, big data, infrastructure technologies, DevOps, and big data. So, okay, and we are going, it's a difficult to adjust to new conditions. I'm feeling like I'm too loud, or not? For the room, okay. Because it's too loud, it's even less understandable than it's. Okay, so what I will be talking. First, I will give you motivation about why cloud computing is important and which role cloud technologies play in different modern technologies, and specifically in telecom area. And I will refer to actually models that is accepted by 5G technology. And after that, I will give you some cloud basics and also more information specific to link you between the telecom, cloud, and actually hardware, computers, about virtualization and containers, Kubernetes. So I would just want also to repeat that this is quite educational, because you are doing the high technologies, 5G, radio access network, which is also goes to virtualization, but you need to have a basic. I just want to ask, how many of you already have experience of working with, say, native cloud technologies, like Amazon, Azure, or Google? Not many. Not deployed virtual machines, not deploying load balancer, also monitoring of computers. Yes, this link, which is here in the slide, and you all received this link in your email, contain directory that contains all these materials, including practice. Practice that you will do yourself. I don't know how much I can in this installation to show you how quickly to create VM, but you can do this. And there I also refer to such possibility that exist by cloud providers like Amazon, free tier. Free tier, this is a huge amount of resources, especially important for PhD students, that you can use to do your research. You get $100 credit, or 100 or 200 for 1 year, and after that, abundance of free resources, which is sufficient, what for our experience, sufficient for doing research during 1 year. In this case, you can deploy like 20, 40 VMs a month from free tier, so you will not spend your $100, and model everything what you need in to collect data. And by the way, knowing what kind of monitoring in cloud exists, you can actually count every bit and every input-output operation on VM, on network, on communication between containers. And this will give you very powerful instrument to do your research at the level of virtualization. And okay, now I sit at the table because I need to do the local mouse to and go into motivation. Just making the few steps back in time. Currently, many of you probably heard about so-called hyper cycle for emerging technologies by Gartner, and I like very much to check what is ahead and what is important now. And if you see what they project for the years after last year, including for this year, this is composable network, composable applications, self-integrating applications, active metadata management, named data network. So network become data network. And we are doing a number of research projects in Europe, okay, big initiative in Europe, to manage research data and technology, how to correctly manage data. I don't know, just once more, I will rise and ask question. How many of you heard about so-called FAIR data principle for data management? FAIR, F-A-I-R. 2, project member. Okay, you're all disqualified because you are not students and you are quite actually experienced researchers. And so maybe next school will be about this. Why? Because data management is important for you. And if we build the slices infrastructure for doing research, a number of experiments will be so many that simply naming the research my project or my experiment will be not enough. We need to go for named directory, metadata, and so on. And reusing data, if somebody made experiment, to reuse this data, you need to provide so many data about your research and data. So this is what's called metadata. And finally, what was even for me was surprising, that Gartner defined the sovereign cloud and industry cloud. What does it mean sovereign? Sovereign also interesting movement in Europe. How many of you not European? All European, okay. So all cloud providers, big are American. And Europe, since already possibly 2018, is thinking how to not become build own cloud, how to ensure that the most valuable part of our, say, using of cloud is data to be sufficiently protected. So sovereignty means not building separate cloud, but building such conditions that everything what is done on the public cloud, like public providers, cloud providers, is sufficiently protected. And this is also high technology. Is it trust, whatever? And by the way, 5G network is sufficiently using technologies that is capable to protect everything what is done in a slice or in a private cloud provider, okay, network provider or telco. You probably hear 5G allows for, at least what I hear. I'm not telco specialist, but I'm interested in all technologies that allows to do everything with computers and data. So if we go for the virtual network provider, we need to make such conditions that everything what is happens in the private network, like big telco companies, that happens also was comparable to the virtual sub network that can be created like virtual provider. So this is technologies that are recognized by big expert community like Gartner. And if you look at the last year, I can, because it's paid data, I can do this, find information 1 year later. So again, they talk about composite architectures and so on. But shift from previous last year to the current, to this 20 to 21, is that you see increase of different composable networks that need to do kind of quick deployment, quick development. And exactly composable element or feature is a feature of the cloud native. So cloud native means that you design network with a possibility to compose, to create a number of components, patterns, templates, and do composition by simply combining this function. And all underlying infrastructure and management infrastructure should do this. And cloud will do for you. So if you believe in cloud, know what does cloud do, you can simply start designing from functional diagram like UML or other architecture presentation to the cloud and deploy it automatically. 2017. Why this is interesting? Because at that time was kind of first time that in their diagram, cloud computing and big data disappeared. Why? Because cloud and big data became simply commodity technology like programming language or like anything what you can do with using your services. And this is last year, 2013, then cloud computing was present on this diagram. So this means this is a slope of rising interest. This is agitation about technology. And after that, this is plateau of say production or enlightenment. So people started using technologies that are actually generally available, recognized, and became production. Okay, so kind of for you to maybe revisit this. And what happened is this cloud provider business is that, okay, we have three big providers like Amazon, Microsoft, and Google Cloud. And you also possibly later will see that different countries has a preference to different cloud providers. For example, there are countries, definitely United States, it's Amazon, Europe, many countries like Azure. Maybe if you will have time, I will explain why Azure has a only. Oh, I will be talking about security in the last day, and I will explain what is difference from point of view between clouds about security and Google Cloud. But you see different 30, 19, 20% and 7%. and Alibaba. Alibaba is a cloud, Chinese cloud provider, but all my attempts to get trial accounts from Alibaba was actually unsuccessful. So they are mostly serving their own community. But anyway, this is a big cloud provider. And going further, and this information from one of say overview about cloud technologies for telecom market. So if you see that in some places that cloud business that rising to the like 20-30 billion per year. So telecom business only on network cloud, you see in the again, it's a volume of 114 billions only on network, on the cloud part of the network. So telco understood the power of cloud and exploring this, and investing a lot of monies. But how they do this? You should understand, or you can understand that there is cloud providers that have a huge internal network that's spanning over the globe, and telco is also network. What kind of network? So they cannot actually use Amazon or Google for their major business. They need to reproduce or recreate cloud for themselves. So here is rising the open source software, open source cloud software like OpenStack, also cloud stack. And around, no, it's from 8 to 9 to from 7 to 8 June, there was open infrastructure summit in Berlin. There OpenStack, this consortium of companies that support development of OpenStack, they announced that the power of their software is already comparable to the major cloud providers. For me, it was very interesting to attend and listen presentation. I did my presentation in this forum and to understand that this is really cloud platform that we can use for all cloud native applications and development for telecom and for 5G and for experimentation. So this is, again, shows you importance of this. And just summary of what I was saying, this slide simply saying that cloud becoming core technology based on which you can use for different industries and actually transform it to using the major, say, features and benefits of cloud. Means the defining services template, composing them, powerful management and monitoring. If you will learn about cloud, what do you first kind of labs, a lot of tutorials. Just I want to advise you to pay attention how detailed can be done monitoring in the cloud. Why cloud providers did very precise, very fine granular monitoring? Because they charge money. So they charge money for every bit, every bandwidth, every data transferred between inside VM, between VMs, and in the network. So developing the powerful monitoring system in cloud, where you can also learn how to do this. Also, something educational part of the cloud. And again, cloud is so powerful. They develop so many specific technologies to run their huge data centers, how to optimize network. They even develop own version of the TCP for data centers. Have you heard about special TCP/IP profile that say optimized for the data center communication? Actually, what does mean cloud provider? Cloud provider looks like a computer center size of few football fields that has racks of machines. Inside these racks, a huge amount of cables, optical cables, and also Ethernet cables, 10 gig, whatever they can achieve, and everything is run between VM in both communication. And to make all this kind of virtualized and composing different part of VM, segmentation of this real physical machines is based on the communication between this VM. Just want one thing to say about network in cloud provider physical data centers is that they have principal difference. They have at least computing units in cloud providers has two Ethernet interface. One for control that is only accessible to the data center management personnel, and one for users. So in this way, they protect the possibility that personnel in a cloud provider can access user network. We will talk about this about security at the security tutorial. Okay, so going first. Now we will try to understand what is quickly about what is cloud native, cloud-based, and cloud-enabled. Again, especially for remote people, you got all links. You can download this presentation and check and possibly ask questions. So cloud native, as a people born in cloud. So if you want to design cloud native, you need to understand the essence of cloud and possibility. First of all, this is scalability, accessibility, access to resources, variety of resources, and possibility to compose them. And also possibility of using patterns that are typical for cloud. Like instead of using load balancer as a network device, you simply can say, I will put here function load balancer in a cloud, and immediately during provisioning of the cloud resources, the provider interface will ask you how many machines you put into balance cluster. And you simply say 6. How you do the scalability from 2 machines to 6 machines? What is your criteria? And this will automatically configure this. So either you use this or you know how to design this. Again, we always will be thinking about either we'll use a public cloud provider, like big cloud providers, or we will use our cloud software to deploy the services. As I mentioned, OpenStack declared that their functionality is currently similar to the, say, Amazon or Azure. This means that instead of digging into documentation, very good advice and what we use for our students is that we give them possibility to work with real cloud, native cloud, saying that this will give you experience what you can do with your own cloud platform, like OpenStack or CloudStack. So this is kind of possibility. So cloud native means that you know what cloud can do, what cloud platform can do, and immediately starting thinking about this. There is one cartoon, something like later about DevOps and other technologies, but looks like from thinking cloud-based thinking. You know that cloud allows you to do easy composition. Use templates and connect. Inside cloud management software, this will be done automatically. Simply templates are done in the special language that understandable by a cloud management software. So you can, again, split your services on smaller components that you can reuse because of, say, easy composition. Another very powerful feature of the cloud, you create your infrastructure, you run, you see some problem, you say, suspend your infrastructure, and all VMs will be stopped and stored. Sometime later, you return back and you continue experiment. So if you don't need to start up, configure at the beginning, everything is you can do, say, automatically because of function. Okay, so this is kind of cloud-based, something like you design your application like on your private hardware or computer, and after that move to cloud, connecting virtual storage, virtual computers, different scaling and possibility. And another is cloud enabled. Maybe I would not, okay, I use what is in community terms. Cloud enabled means that you have a fully created stack, you simply moving from your local facilities or data center to the cloud. This is very simple. I know that what some researchers even create, move to cloud their virtual machine with port run. I personally doing what I have an old photo scanner that works only on Windows 7. So I created virtual machine Windows 7. If I need to work with scanner, I simply deploy or start the virtual machine with Windows 7 and it works. So this is like cloud-enabled technology. Going further, no, this is back. So this is what I already mentioned. Just catch in this slide the keyword OpenStack. So OpenStack is something what I see already sufficiently ready for all experimentation with all power of cloud native. And I will use a couple of slides from the 5G documentation or publications, white papers that show how this goes in cloud native use in architecture. So this is slide just to show you that cloud native and where is cloud expected to use. In the 5G core network, SDN and NFV. Also edge computing, middle edge or metropolitan edge. I don't know Mac, I simply forgot. What? Mac? Mobile edge? I hear different, okay, but anyway, this is something difficult. Yeah, this is what evolution of cloud native technologies. Something what I already mentioned, what they do, that they say that a cloud native cloud current technologies using virtual function network function and using a container network function using Kubernetes platform, but based on the platform OpenStack and what telecom companies thinking that they can move in the future that Kubernetes that currently runs on the typically on the special platform between bare metal and operating system, and they want to like replace Kubernetes with operating system with Kubernetes. Providing Kubernetes is a orchestration and management system for containers. So this is a future, and here they also define a service-based architecture. That is, service-based architecture is a future architecture for the cloud native, and so service-oriented architecture is an initial technology of cloud technologies. So all VM and all cloud management is actually based on the service-oriented architecture. And if you look at the history of this, you will find what does mean. It's a web services, pub/sub, publish subscribe technology, stateless, stateful services, and so on. This is service-oriented architecture. For you to also to link cloud 5G, I simply quoted this kind of very rich, this acronyms slide that explains how they can do service-based architecture, deploying all these service components as a containers or as, okay, virtual machine or containers. And how it's different. This is 5G presented as a set of specialized functional modules, possibly deployed on a special telco vendors equipment like Cisco. So this is boxes costing a lot of their physical. They have very one benefits this architecture is reliability, because they are designed to be reliable. If you move to the service-based architecture, you have VMs that deployed dynamically on demand or at the moment of deployment, but very often they are run in a big data centers on a built cloud cluster. This means that this architecture, service-based architecture, has a one trade-off. It needs to be designed for the possible failure, because big data center, a lot of concentrating, say, resources, typically not on the facility of the provider. So cloud providers give you 3 nines, but sometimes you probably hear that if in this 3 nines cloud provider, one service is failed, half of the infrastructure doesn't go. Like in Amazon, it was fairly only one log system on a Kafka, and 1/3 of America, United States, stopped working for a couple of hours. So this is good and bad of this kind of architecture. So in these models, management and monitoring is local for each function. Here is management and monitoring typically is centralized because it's done by underlying cloud platform. And one more, what again, researchers in 5G say that comparison between, this is about moving from this architecture to this architecture, whereas OpenStack is a central, this is transitional, and this is future where we want to rid of cloud based platform. They show what is performance issue, deployment. And I must say that infrastructure deployment, 65 minutes, it's 1 hour. If you will deploy in Amazon cluster, Hadoop cluster for big data processing, 4 VMs take 15 minutes. If you deploy simple VM that take 100 gigabytes of storage and like 4 gigabyte memory, it takes like 8 to 15 seconds. So all these underlying management infrastructure services, they require some time. And again, even if you use a template already existing image, you need to load this image to the computer, after that deploy it and so on. Install, configure. So Kubernetes is more lightweight, or containers more lightweight. We will see later on the underlying technologies, some kind of visualization that we use in our, say, courses about cloud technologies, why it's a difference. And you see what is kind of other performance issues. Okay, and now we will possibly summary that here I would say, just to draw your attention, that cloud at the beginning of their say use or promoting, they claim that cloud allows to to speed the deployment and development of services. So DevOps technology, development and operations, as agile technology, probably many of you here even have friends who work as a DevOps engineers or operational engineers. They use this technology, but they use a term infrastructure as a code. And many of you probably know this kind of deployment tool like Ansible, like Terraform, like whatever, Chef or Salt, popular also in telecom business. So they all use technology infrastructure as a code, where you describe your infrastructure, which VM, how to configure, what is domain, what is addresses, and so on, and simply run inside this tool, run this template, or they call recipes. They call also different kind of plays, playbook, and so on. You run this through the, for example, Ansible or Chef or Puppet, and this step by step deploy your infrastructure. And by the way, cloud providers, the telco providers exactly do this way. So they use DevOps technologies, and cloud is something what was mutually accelerating. DevOps, these cloud technologies, and cloud technologies actually change and accelerated DevOps, and so on. Yes, final item is VM against vice containers. There is such term in containers as noisy neighbor. If few containers deployed on one physical machine or one virtual machine, they actually may compete against for resources inside the same VM or same physical machine. So the major issue currently is to make this possible, that each container has own part of resources of virtual machine or physical machine. In virtual machine, it's done based on the BIOS level, on the kernel level. And containers principally don't want to go to the system level of the virtual machine or physical machine. So this is a research, what is done in this area. And okay, do we have some question before I move to the another part, which is about basic cloud foundation issues? I will check if there is some I don't know if it's to me. No, this is not to me. Definitely, because I don't know what it means, this question. Okay, now we will look simply basic concept of cloud computing. Anybody knows difference between infrastructure as a service, platform as a service, software as a service? Have you heard about this? Okay. Even if I would say so, that at current level of development of cloud technologies, you probably even don't need what is this. But knowing that cloud started from this, also quite beneficial. So, as I mentioned, also for you, for your general understanding, cloud technology created first time term cloud appeared in 2008, and they defined basic features or characteristics of the cloud. We will look next slide. And it took 3 years to make the standard, what is NIST standard 800.145. They defined this. And importance of standard, that if standard are defined, everybody started using compatible development, compatible research, and industry technology is just very quickly developing. What 5G? 5G, 4G, I don't know much about these terms, is very rich, this standard. Standards is extremely complex, tens and hundreds of pages. But this allows different vendors, providers, and companies to develop compatible technologies. Surely compete. In a competition, technology is maturing. And cloud, exactly the same way happens. So this standard was published in 2011. And typically, I would say, since that time, we can say that cloud is established technologies, but you can find a lot of publication, especially research publication on cloud that are dated from 2008, 9, 10. I would say sometimes they define and develop the topics that are not purely cloud. So if you want to work with real cloud technologies, look at the publication, look at after 2011, possibly 2013. And what cloud defined as a 5 basic characteristics, we will, I will pronounce them and let's think together. On-demand self-services. What this means? That cloud providers collect a lot of resources, VM, storage, whatever, routers, different points over the world where you can connect. And they provide you possibility to configure your application or infrastructure yourself. Their task to create nice interface. And they don't need engineers who will do this for customers. They simply provide these facilities and maybe sometimes train them or make a first implementation of the product. After that, stuff is, say, doing themselves. So cloud providers created business on which they need less engineers, and everything what the customers do themselves. On-demand self-service. Broad network access. Now it's even difficult to say, understand. Then cloud was started developing, spreading over the world. Surely it was spread first in the Western world. But then companies started moving to Africa and Middle East. They just discovered that telecom legislations something happens wrong. Maybe pressure changed and sound speed is changed. Okay, broad network.
Yes. We will speak to Mike.
Okay, so broad network access. For customers to work with cloud, they need access. For companies to run services on cloud, they need to assure that their customers will have access to cloud data centers, because all services in data center, and years like 2011 to 2013 was like a lot of change in legislation on telecom business in many countries beyond West. Resource pooling. Resource pooling means that cloud provider collect resources, VM, storage, network, and make them in such a way that they can be combined together and used and pooled together. For example, if you order 1 terabyte storage, definitely cloud provider connect to your 1 terabyte order storage from different racks, machines, and vendors. So inside cloud provider is very strong and reliable standards, how to connect all these components. Rapid elasticity. Rapid elasticity means that if you want to increase size of your service in cloud, you don't need to call somebody or order something. You simply need to say, if load increase, extend number of VM. And this is done in cloud automatically. And measured service. This is what I mentioned. Cloud provider charge customers for every bit, every byte, every second of working on their resources. So they needed to create a very powerful monitoring, management, and say auditing system. And here you can also learn from them. And they defined initially 3 types of services: infrastructure as a service, where you get simply VMs, platform as a service, where you get development environment, and software as a service, where you get services like Dropbox, Google Drive, whatever, Google Docs. These are software as a service. The complexity, so if you want VM from cloud provider, say, I want VM, and you deploy everything what you want on this VM. Application, services, website, different storage, directories. This looks like you own VM. If you use platform as a service, you get something like development on Python notebook or Jupyter notebook on cloud. You have development environment. You have beanstalks connecting services between them, like in cloud providers. In software as a service, they simply use a service. It's difficult to imagine what is the complexity behind, for example, Google Docs or Google Drive. Did you have a problem that you accessed somebody's document in a Google Drive? Probably not. All documents are stored on a in a Google Doc are reliably separated from one customer from another. How to do this? It's an art of so-called multi-tenancy services design. They use such powerful technologies that it's difficult to imagine. And this technology actually can be reused for making kind of virtual or cloud native telco infrastructure. No, it's something like terminology: private cloud, public cloud, hybrid cloud. At least now we are living this private cloud and public cloud. Public cloud is a commercial service providers. Private cloud, what is done by companies inside their data center. What is currently statistics? Company, if, for example, first years of using cloud, somebody would qualify, oh, we use private cloud. We use only public cloud. Or we use one private cloud, our private cloud with one public cloud. Currently, if you see, companies are using variety of models, and everything is integrated very easy. So even understanding that you run, for example, website on virtual machine in cloud and using Google Doc for storing some documents is already not trivial, but still effective, because to the storage is easy to access and collect information, and you simply access this Google Drive for your website on a cloud. And here are a lot of technologies that are enabling using multi-cloud. First of all, if you are using access to use multi-cloud technology, you cannot say, I'm using 10 cloud providers and I need 10 accounts in 10 cloud providers. Who can do this? Especially if it's a production network. So this means that passwords should be strong, many characters, and what you will put this on a list on your smartphone? No, this is not go. So for this purpose, use the federated identity management, where automatically all these accounts are propagated based on trust between providers. You can use your company account for accessing majority of cloud. You see, currently federated account management or federated access is offered even Facebook, Twitter, LinkedIn, because you are coming to some hotel reservation and they ask, will you use our account or your Facebook account? I don't know what you decide, but I don't like mixing this account. So at least for not my professional, I'm not mixing them. Okay, but for this purpose, is the most popular is Azure Active Directory, that any cloud provider has special VM or service to integrate Azure Active Directory, Microsoft development, to all infrastructure. Amazon offering their so-called IAM, Identity Access Management, and Amazon Cognito that make a federation. So you put account one in Amazon IAM, you can use this account for every service that you deploy, whatever you create your infrastructure. Multi-cloud automation platform. Currently, all DevOps tools, CI/CD, continuous integration, continuous deployment, has access, template, and library to connect cloud of different providers. This is Ansible, Chef, Puppet, Terraform. Anybody has experience of any of these four? Ansible probably. Keep in mind, Ansible is written, Ansible recipe or playbook is written very simple and you simply define which machines, which configuration you need to them, and you run this, and it creates you automatically. Okay, software-defined network is a powerful technology that is mentioned here not in the context of telco business or 5G, is used inside cloud provider. Inside cloud provider, this software-defined network is so powerful that they provide sufficient isolation between different network inside cloud provider data center that even certified for health care application for hospitals. So hospitals trust cloud providers to create sufficiently secure network. And by the way, in the United States, maybe you already heard some publications that Azure won bid for creating cloud infrastructure for Ministry of Defense, United States. You can understand what is the level of reliability and security in this kind of in this infrastructure. Compliance and maturity assessment is what we will talk on Thursday. And this is one of the foundational slides about cloud technologies. Will we finish or make a break? So what organizers say? Because it's only one third of my presentation. So I count that what I'm doing slowly at the beginning, giving you basics, that will be easy for you to learn more detailed technical information. What is the next slide? So this slide shows a comparison between different service models in cloud. If we look at the say it's a cold package application that is deployed on your own data center or your own machine, it has all layers like virtualization, operation system, middleware, runtime application on one computer and managed by user. If you use infrastructure as a service, underlying infrastructure part managed by cloud provider. And you create your virtual machine with your own operation system, runtime, application, and data. If you do the platform as a service, means that all platform that allows you run services provided by cloud provider, and you only create application. If you use software as a service, where application like Google Doc, Google Sheet, Google Drive is completely managed by providers. But principal issue that cloud providers don't have responsibility for your data. If data breach or if somebody steal or destroy your data, cloud provider doesn't have responsibility. But cloud provider provides sufficient amount of security tools, instruments that make this correctly and protect your data. So data is always responsibility of cloud provider. So I will not stay much on this slide, just saying that cloud provider is not only one role or player in cloud business, because at least there is a cloud consumer or cloud customer, at least two, but also cloud auditor, a cloud broker, and cloud carrier. All these roles are important in business. Cloud carrier is a strange role. This was included in 2011, but now cloud providers have a so powerful network that they probably don't need cloud carrier. At the same time, telco that played role in the past as a cloud carrier, they are currently becoming themselves cloud providers. And if they will start deploying the cloud native telecom services, why not them offer the general cloud services like file sharing, file storage, like big data processing, cluster deployment, and so on. No different, because all of them are using the same technology. So became the convergence between everything. We will not stop. Use cases. We can talk a lot, but I will spend couple of words, just couple of words about use cases. These use cases, as I mentioned, this is classical from 2010, even before the cloud standards was created, but they are very, very much illustrative and educational. So, mate, it's a cloud burst. Cloud burst means that if you need to increase power of your services from your own data center to serve more customers, you can deploy part of services in the cloud. What you need for this? You need to understand at which moment you need to extend your services. This is like load balancer that need to trigger moment that you can deploy services on the cloud, and after that, deploy services and redirect part of customers to cloud. And finally, you will only run services on the cloud. But for this, you need to solve problem load balancing. You need to service all your templates and VM and move them to cloud. One more issue is a disaster recovery. Disaster recovery is one of the principal elements of, say, cloud. Disaster recovery solved for real infrastructure if they destroy it because of war or nature disaster. You need to restore services. Easiest way to restore them in the cloud, because cloud resources so powerful that they cannot be destroyed. The cloud provider is having every infrastructure is highly reserved and reliable. So you need to define backup and possibly deploy different services because of disaster on different cloud where it's possible. So if you run services, email, file storage in your data center, you may deploy web on one cloud provider, email in another, and possibly you already, many universities already experience it, that they completely outsource email to one of Gmail or Open or Outlook and so on. So this is like happening. Another issue, change in cloud provider. Despite many claims that cloud providers, cloud can improve sustainability or continuity of your business, there is a term as a cloud lockup. If you start with one provider, you may have a difficulties to move to another provider. There is even special service from cloud providers to move from one cloud provider to another provider. It's not like in mobile, saying, or internet. If you want to change provider, we will do everything for you. It's not big work, only talking between offices. But if you move infrastructure from one cloud provider to another, is a really problem. So you need to say store or package all your VM, all configuration, in one provider to move to another, to convert them, and so on. So, okay, I will not stay on this. I will simply finish today on this module. Virtualization, containers, and Kubernetes. So how it looks like. Cloud is entirely virtualization based, initially based on virtual machine. If you look historically on how the technology were developed, so if you run on your machine, you have hardware, computer, operating system, and application. It's difficult to say that if you run Word on your personal computer, it's just simple application. It's not. It's already connected to cloud. But if you develop this was 20 years ago, develop website to make some kind of isolation between operation system on the server, you create service container of initial container, Tomcat service mix, maybe somebody still remember, or majority of people young enough not to understand what is this, not to remember. If you use cloud providers, you have host operating system, you have hypervisor. Hypervisor does virtualization of all elements of physical infrastructure and operating system and allow them to use by VM, depending on assignment and sharing of resources. So, cloud, we have a cloud provider, so simple virtualization where you have guest host that is implemented in the same way as here. So what is the outcome of this? You have one more attack typically happens through this channel from the users, and it goes through the service container operating system to the host. And if attacker penetrates at this level, that they have full control of your system. Now you have one more defense line, hypervisor. If you go to cloud, you have one more layer, is a cloud management system. Either OpenStack or the Nebula, or we don't know how it's done in Amazon or Azure. So it's one more isolation level. In cloud providers allows to create virtual private cloud that creates a fully isolated network inside cloud provider that may include many machines. So this is very powerful system. And if you compare in this kind of cloud implementation, cloud management system, and container is actually replacing cloud management system with containers. It runs on the hypervisor optionally or directly on host operating system. And this is what you see in the diagrams at the beginning, how the telco and 5G looks at the cloud native. So containers remove cloud management and possibly hypervisor. What does it mean? It's performance. And this is what makes containers more preferable for high performance and very active communication, especially for input-output. And if you want to know more about cloud native computing architecture, go to Cloud Network Computing Foundation. I will not stop here too much time. This everything what at the end will go further. Kubernetes, architecture of Kubernetes that has different pods where you put few containers, and pods has some kind of isolation between different pods. But normally inside pod, all containers can affect each other. So if you use a high performance application or services, you need to slightly correctly distribute your services between different ports. And node can contain a few ports. And this number of nodes create cluster. Yes. Something this I would finish at this moment because of time. And next two blocks has an overview of DevOps tools, example for metrics on Amazon, and an example of a cloud provider. This is a lot of technical information. I would say you will read and learn yourself. Okay. Looks like I finished like pen in amount of time. Okay. Now questions. Oh, Serge, one question.
No, oops. I just wanted to thank you for keeping us late in the afternoon. Questions? Are there questions online?
It's old question. Only one. Probably looks like this is not for me because I don't know what that means. Okay, let me ask question. Did anybody convinced that you need to learn cloud and spend some time to understand what cloud can give you? And I answer question, yes.
So you don't see any drawback or weakness using cloud native, like with respect to energy consumption, for instance?
I would say that telecom business and 5G architecture is already moving to the cloud native. So the only problem what I see that say fully concept of cloud native based on containers maybe not applicable to some application because containers still affect each other. Like you see, containers inside one pod and one node affect each other. So if you have one quickly communication container, for example, using the streaming, and another is serving web server request, they will affect each other. But in the previous slides for 5G, you see that they are working on this. And OpenStack just tried to convince everybody in Berlin that they will solve this. One more problem, this going to cloud native, you need to learn. You need to learn basic technologies. And this spends some time. Experiment. But you can do this with a lot of courses, training courses, free resources, because cloud providers interested that more people know, they will more use, they will bring more money to them. But at the same time, you can just understand this will allow you faster solve your research problem, development problem, and deployment. So this like this. Oh, you got this.
Thank you so much again, Yuri. Before we close and before we remind you that we will start tomorrow at 9 a.m. sharp, I would like to hand over for a short announcement.
Thank you. So on Thursday, we'll do some hands-on with automation tools like we just presented us today. So this is a lab that you will practice on yourself. Basically, what we will do is to deploy ONF functions on BMV2 switches in an automated way, and also in a real environment, but that I will be the one doing it. So people willing to do this lab hands-on with Mohammed over there, we can prepare the setup for you. So basically, we need to install Vagrant on the machine as well as VirtualBox. And initially, we were supposed to do everything online, but the network here is really too slow, if not unstable. So we prepared the images that you can get. There are 4 gigs. So it's better to download them now or tonight at the hotel or whatever, or we can provide it through a USB key. So don't hesitate now for the next hours. We'll be here if you want to set up the environment for Thursday. Because tomorrow night it won't be possible because you will all be on the beach. That's all for me. Thank you.
So there is a question, says, not sure if the question is too basic, but there are recommendations for getting started with Kubernetes. We will have access to lots of physical machines to work with.
Yes, okay. I'm not sure if this question, okay, is too basic, but there any recommendation for getting started with Kubernetes for people who have access to a lot of physical machines to work with this? Most tutors advise starting this Minikube or AWS. If you start this private machine or a lot of resources, you will work this one machine, or if you want to do this deployment on many machines, like creating test bed with 10 or 100 nodes, you need to do this either manual or run Ansible or Salt, specifically designed to deployment on many machines. It's still some time of work. And still your experience will be locked inside this 100 machine that you own, an Ansible playbook that you can create. So I would say it's a better approach if you know your task on your own machines, try something. After that, go to what you Minikube, I don't know what is this, or go to AWS, Elastic Container Service, or Azure, very powerful container service. Learn what they can do. After that, replicate to your own environment. Another story. If you do on some private platform for containers or whatever created, maybe some even respectful telco, you will be still limited inside this platform. But if you do the standard configuration, standard platform, you can move all of your containers, all of your configuration between different platforms and between different providers. So there is a tendency. Then companies started working this hybrid cloud, means combining private cloud and the public cloud like Amazon or Azure. They started implementing in private cloud the same cloud stack to easy migrate resources and to easy integrate them. And Azure even provide their stack to be deployed on your data center. It's an example. But again, I'm repeating, and first time I seen this in the Open Infra forum, that OpenStack is powerful enough. So what we will do at our university, we will investigate how much OpenStack is powerful now. We will start implementing this for teaching students, not only on Amazon or Azure, but also on OpenStack. Maybe it will take 1-2 years to readjust the kind of education. But again, investigate options, at least look through tutorials on Amazon or Minikube, and you will learn much better what you can do at your own data center. And again, using the same platform in private data center installation that is compatible with this cloud gives much more benefits. This is the approach. Okay, another lecture.
Thank you. And that's all for today. Enjoy the evening. See you tomorrow. Ciao.